Hey everyone, moving on to the question types, we begin with finding square roots to complex numbers. Now, unlike square roots of real numbers where there are only one solution, so let's say root 4 gives us 2, minus root 4 gives us minus 2. There are only one solutions per square root for real numbers. In complex numbers, there is no distinction whether a complex number is positive or not because they are imaginary numbers. There's not really a way to decide whether an imaginary number is positive or negative. As such, we will actually get two solutions per square root of a complex number. So how are we going to solve them? Let's start off with an example. 3 plus 4i. Now, we know that the square root of a complex number would be another complex number, or two complex numbers rather. And we are going to, let's say, represent that a solution as a plus bi. Now from here, we just need to square both sides, and we get 3 plus 4i equals to a square minus b square plus 2abi. Now, then the next technique to do is something like comparing the coefficient, but in complex numbers, we kind of compare real part to real part, imaginary and imaginary part. And this idea will also carry on in some of the question types as you see in the future videos. So we have real parts, a square minus b square equals to 3, and then we have real imaginary part, 2ab equals to 4. So from here, right, I think it's quite obvious what you need to do. Equation 2, equation 1, you can make equation 2 to express a in terms of b or b in terms of a, substitute that into equation 1 and then solve. So I'm going to show that method, and then I'll show you the other method. So from equation 2, I'm going to write that in gray. So we have a equals to 4 divided by 2 divided by b, so 2 over b. Substitute that back in a square minus b square. We have 4 over b square minus b square equals to 3. Now you can actually solve this from here. It is possible. But for some of you that cannot see it, multiply everything by b square. You then get b power 4 plus 3b square minus 4 equals to 0. Now some of you might be like, oh no, what can we do? Do I need to solve a quartic? Answer is no, you can treat this as a quadratic by letting b squared instead of considering just b. So we have b square, let's see, plus 4 and then b square minus 1 equals to 0. So from here we know that b square equals to minus 4 or b square equals to 1. Obviously we reject this one because b square is bigger than 0. From here we have b square, b equals to plus minus 1. Now that we have this, we substitute that into the second equation. So we have 2a plus minus 1 equals to 4. So actually you can kind of already solve this. Actually you should equation 3 rather. We have a equals to plus minus 2. Then from here we have the solutions 2 plus I and minus 2 minus I. Now you notice that the complex numbers of solutions are actually differed by a negative sign. We know that minus 2 plus I equals to minus 2 minus I. Similarly, minus bracket minus 2 minus I give us 2 plus I. Whilst the other method is actually obtaining a square plus b square. So what I'm going to do is I'm going to get a square minus b square whole thing square to give us 9. And I'm going to get 4a square b square equals to 16. From here, I know that a square plus b square whole thing square is 25, right? You add these two together, you actually get the left hand side as a square plus b square whole thing square. You can expand this equation to see for yourself. Then I know that a square plus b square equals to 5. You reject a square minus plus b square equals to minus 5, since we know that a square plus b square must be bigger than 0 or equals to 0. Then we can actually finally solve. If this is equation 3, we just combine equation 3 and equation 1. We know that 2a square equals to 8, a equals to plus minus 2. Put that into equation number 2, b equals to plus minus 1 as well. So really any method works. It is your call. All right. Now, just going back to the first method on why so you can actually solve this immediately. let's say I got b squared plus 3 minus 4 over b squared equals to 0. Actually, from here you can solve it because you have b plus 4 over b minus 1 over b equals to 0. Yeah, it's surprising, but it works. All right. So yeah, there we have it. Finding square roots to a complex number with two different methods. Pick your favorite one. Regardless, the more you do this, the faster you'll get. You can actually skip some steps, like for example in the second method, I know that adding these two together will give me 25, and then I can take the square root afterwards. Alright, so choose your favorite, and I'll see you guys in the next video.